Hello, my name is Gabriel Schaefer. I'm an undergraduate student at Penn State Brandywine, and today I'm going to present you my research on the measurements of air and surface temperature changes in southeast Pennsylvania during the August 2017 solar eclipse. So I took advantage of this past solar eclipse, which occurred on August 21st, 2017, to see how the solar eclipse interacts with the local environment in terms of air and surface temperatures. So how I collected the data: I used for the air temperature, I used air temperature probes, and for surface temperature, I used infrared thermometers to collect the data for the surface temperature. As of the site themselves, the data collection was done on campus. Since with the air temperature probes, we're required to record in the shade, so we made sure that the data collection was done in the shade, and also they were at least 100 feet away from any concrete structures, so any heat that might be coming off of those structures don't interact with the probes and the temperature reading that we might be getting. Along with that, the temperature probe was 5 feet off the ground, so the heat from the surface and the air do not interact with each other, and thus reducing the amount of obscurity that might be done with the data. So moving on to the results, the data collection themselves. So how the data was collected. We collected the day before, the day of, the day after the eclipse. So we can have a good baseline reading of how a day without this eclipse looks like in terms of temperature, and what it looks like the day of an eclipse, of how that looks like. So looking into the day of the eclipse, starting at the highest temperature before the eclipse, around 1:20 p.m. till maximum obscurity. That was over a course of an hour and a half. The site witnessed a 4.5 degree Fahrenheit per hour decline in temperature. And going out of the eclipse from 12:43 to the remaining 2.5 hours of our data collection, we saw a 2.04 degrees Fahrenheit per hour increase. So comparing the two rates of decline and incline, the rate of incline is half the amount of the decline. So this 2.04 degrees Fahrenheit per hour may indicate natural fluctuation, or a natural recovery from an event like a solar eclipse into normal conditions. And the surface temperature experienced similar fluctuations in temperature, plus or minus 4 to 5 degrees Fahrenheit per hour, and plus or minus 2 degrees Fahrenheit per hour. And comparing this to a non-solar eclipse day, so the day prior and the day after the eclipse, showed here, the rates were about 2.6 to 0.8 degrees Fahrenheit per hour. So that we can use is the natural rate of temperature increase over your average day without any major weather events. So in conclusion, with this research, I'm hoping that we can use this data to predict how the temperature might fluctuate on event of an eclipse, so we can accurately forecast what the temperature changes for both air and surface would be. Thank you.